Hey everybody, this is Courtney Brown and Emma Jacob, and we will be discussing homework 19 for our digital simulations class at Liberty University. So problem number 19, basically we look at something called reliability inference. So what we're doing, we're interested in determining the survival probabilities for components, and what we're going to do is develop a procedure to perform k number of iterations for an independent sampler. It returns a matrix C, which has k rows, and q plus 2 columns. So the first q elements of the ith row give sampled survival probabilities at specified ages, which is basically y of q. And the last two elements of each row give the sampled alpha and beta of this ith iteration. And it basically wants us to do Bayes estimates for the survival probabilities of ages 1,000 hours, 2,000 hours, and 3,000 hours. So let's take a look at the way we did that in MATLAB. Again, one of the great ways is because we have in our textbook, we have it in Maple. We're able to, it's in Appendix 8.2. We're able to take that program and transfer it over to MATLAB. Alright, so the first thing we want to look at is the first major block is when we initialize our variables. K, again, was what we had set before, being the number of iterations that we've done on an independent sampler. We set that to 5,000. X here is our failure data. Basically, this is our data of when it failed. So 293 hours and so on and so forth. N is our length of X, so it's going to be about 43. And then we initialize the rest of our variables. Y here, so we're going to look at 1,000 hours, 2,000 hours, and 3,000 hours. Okay, so then we go through the log likelihood of finding the failure here and perform k iterations. So again, k is 5,000. We generate random variables r1, r2, r3, r4, and then we run through these iterations to basically give us a likelihood. Using that information, we can decide whether to accept or reject the candidate point that we're looking at, and we can then enter survivor probabilities and alpha and beta values into the ith row of C. And once we do that, we enter it into the ith row of C. We can then look at plots of what that looks like. So we've developed three subplots. And the first one is going to be for 3,000 hours, which is just going to be a mean of that third row that we put into C. The next one is going to be of 2,000 hours, which is going to be the second row, the mean of the second row we put into C, and so on and so forth. 1,000 hours, which is going to be the first row that we put in, mean of the first row that we put into C. So once we run this code in MATLAB, we're able to see a graph. This is going to be our probabilities of survival here, and then this is going to be how many iteration or hours we've done. So that is our problem number 19 for Digital Simulations Engineering 468 Liberty University. Thank you for watching.